Hi guys, today we are going to be solving another easy question from LeetCode. This is contains duplicate. So what you are given is an array of numbers. You have to check whether there are duplicates in this, and if there are duplicates you have to return true. If not, you return false. So this problem could be done in multiple ways. So let's see as to how. First we will be looking at the brute force. Now seeing this, you could say that you have to compare two elements together, right, to check if they are equal. So in the brute force, what you would be doing is checking each element with all the other remaining elements to see if they are equal or not. So how that is first you would be checking one with 2, then one with 3, then one with 1. Because we have both similar here, we would be returning true. But let's just say this was 4, this was 3. Okay, after you finish with all the ones, what you do is you go to the next one, that is 2. You would be checking 2 with 3, and again 2 with the other 3. This is also not equal, so you would be moving forward, and then you would be comparing 3 with the other remaining element 3. Because these two are same, you would be returning true. So for this, the time how you would be having the pseudocode is you would be having two for loops. One is from I equals 0 to n minus 1, or less than n minus 1, and the other is for j equals sorry, I'm making a lot of mistakes, I plus 1 till n. And here you will be checking if array of I equals array of j. If this is true, you will be returning true. Okay, for this the time complexity is, because there are two nested for loops, we would be having O of n square, because this is going to be going till from 0 to n, and that is done for n times, right? So that's why O of n square. Coming to the space, because we are not using any new elements or we are not creating any new elements, so the space complexity would be O of 1. Okay, so this is the first solution. So the next solution that we could follow is frequency count. That is, count as to how many times each character appears. So for this we would be using a data structure called hash maps to store the count basically. So what we would be doing is we would be having a for loop that goes from I equals 0 to n. At each position we would be checking if array of I in hash map, if this is there, we would be returning true. If this is not there, what we will be doing is adding this to the map. Hash map of array of I plus plus. Okay. If it is already present in the map, we would be returning true. If it was not present in the map, we would be adding that to the map. Okay, for this the time complexity, as we have only one for loop, so we would be only iterating once through the entire array, so the time complexity would be O of n. But for the space complexity, because we are creating a hash map of, in the worst case, size n, right? So our space complexity would be O of n. So this is the second solution. Now let's see the third solution. This is sort and count. So what you do is, let's take the example again. Now this is the array. What you do is first sort the array. First you sort the array. Okay. After sorting, the array would be something like this, and then you would be using two pointers to traverse the array. Like you will be having one pointer here, one pointer here. You will be comparing these two. If they are equal, you will be returning true. Else, if these two are not equal, what you do is you move the pointers forward. Again, these two are not equal, you move those again. Now coming to the time complexity for this, because we are sorting the array, it is going to take n log n time plus once for the iteration through the array. So this is n log n plus n, but this will ultimately result to n log n. The space complexity would be O of 1, because we would be considering that this sorting is done in place and it does not take any extra memory. So this is the other solution. In the previous solution, we had a nice time complexity compared to this one that was linear. This is n log n, but there it consumed more memory or more space, while here we are having a constant memory. So different solutions have different constraints and uh, advantages. It's up to us as to what solution we have to use. Okay. There is also a fourth solution. This is an extension of the second one. So let me write this. 1, 4, 5. Okay. Let's consider this as our array. So in the second solution, what we did we had a hash map, and we iterated through the array like this. And then if we had this value already present in the map, we returned it true. If it was not present in the map, we added that to the map. This had us at O of time, space, and time complexity. But we could optimize this further. What we could do, instead of just going in a single direction, that is from left to right, what we could do is have two pointers that converge to the center. Okay, so what you are doing is halving the time complexity, because at a single time you are comparing both the two, right? So in this, what you do is first you compare this and this. If they are equal, you just simply return true. If they are not equal, you will be checking if both of these are present in the map. If any one is present in the map, you return true. So for this, these two are not equal. So you will be checking if they are in map. They are not there in the map. So you add those to the map. And 5 would be what? Sorry, you don't add the index, right? You add the frequency count. Okay. Next, you move the pointers. These two are not equal. You will be checking if they are in the hash map. They are not. So you add them. After that, you move the pointers to the center. Now you would be checking if these two are equal. They are not equal. You would be checking if 3 is in the hash map. It is not there. So you add 3. And then now you will be checking if 1 is in the hash map or not. And it is there. So you return true. Okay. So in this, the time complexity is big O of n by 2. But because we remove the constants, it would be O of n. Okay. Even though both the notations are the same in this one and the second solution, this is more efficient than the second one. But the space is same for both again. That is O of n. So oh, these are the solutions that are there for contains duplicates. As I already said, there are multiple solutions for any problem. It just depends on you as what you need. You either want a nice space complexity, time complexity, or a nice space complexity. There's a trade-off between these two, time and space. If you want good time complexity, you have to sacrifice space. But if you want good space complexity, you have to sacrifice time. So this is how it goes. Now let's just look at the code for the second solution. So what, as I said, we would be having a hash map that will be storing integers. Okay. Now we would be iterating through the array. Yeah, maps. And for each element, we will be checking if that is in the map or not. Okay. If this is true, we return true. Else, what we do is empty of idea plus plus. Okay. And if this was also true, I mean, if we completed everything, every element in there, and we did not find any duplicates, we would be in the last returning false. So this is all the code that is there for this. Let's just submit this. Submit. So this is the code.